Today we're going to see static relay, where we know what is the use of relay. The relay is used to sense the fault from the CT, the reduced current, which will be sent to the relay. That relay, if it sends a fault, and automatically what it will what it will provide the signal to the circuit breaker. Okay, so till before this static relay, we have seen electromagnetic relay, then induction type relay, which will work according to the magnetizing energy. So whatever the current which we are getting from the current transformer, that we will use to energize the coil of the electromagnetic relay, or the magnets, electromagnet, which is available in the induction type relay. Two coils will be there that will energize, and which will pull the contact, and that contact will get closed, so that the circuit breaker will be get connected to the this protection circuit, so that it will open the circuit breaker, so that the fault will not reach the load. This is general process which is used with electromagnetic relay or induction type relay. There we will have movement. Okay, dynamic nature will be there. That relay will work with the dynamic nature. But here we will be using static nature of relay. Static nature of relay means there won't be any movement. With the help of electronic circuits, electronic components, which frames a circuit, which will which is used for sensing the fault. This is also going to work as a relay only, for protection circuit only, which will make the circuit or break the circuit. All depends upon that one gate pulse signal. If you give, or base signal. Consider if you are taking a transistor, emitter to collector. If the current needs to flow, we have to give base signal for the transistor BJT. Okay, similarly, if you like to make a current to flow between anode to cathode, then for a SCR or a thyristor, gate supply needs to be given. So, like your MOSFET, everywhere gate signal is required. Then only drain to source, or source to drain, or anode to cathode, all those current supply will flow. So depends upon that one signal. You can keep the devices on, or you can keep in off condition. So on and off, this can be used for making the circuit or breaking the circuit. Breaking the circuit means we will switch off the device. So making the circuit means we will switch on the device, so that through that the current will pass. Using this concept, instead of using the electromagnetic relay, we will be using static relay. Why we are going for static relay? What is the advantage when compared to the electromagnetic relay? Why we have to go for static relay? The purpose is, there we will have saturation issue in electromagnetic relay, because magnetic saturation will happen. If heavy current flows to the coil, the magnetization, what happen? That flux will be will not vary. Maximum current you are passing, and you are going to pass a low current. Consider, for that the flux needs to be changed, but instead of that, a constant flux will be keep on flowing. Variation of current will not produce variation of flux, so saturation will occur. In such case, the electromagnetic relay will do malfunction. So in order to avoid that, we'll be going for static relay. So you can see here, whatever the current which you are getting from the CTR PT, that will be given to the rectifier, and here we will be using the electronic device. So that electronic device will work accordingly, and it will be given to the trip circuit. This trip circuit is separate. For this electronic circuit to work, for that the DC supply is required. As I have already told you, that one pulse will be given via this. Once if it is sensed, that fault, that pulse will be given, or gate pulse or base supply. But anode to cathode, that supply is required. That supply will be given via this anode to cathode, or emitter to collector. That current will be given here. This current needs to flow means who will give the pulse according to the fault occurs. Accordingly, the pulse will be given. So here the static relay, why we are going for electronic components by replacing the electrical component means electrical component generally will consume more power, but electronic component will consume less power. That is why the static relay, which is made up of electronic components, will consume very less power. And this will will give us quick response, because on or off, two conditions you have: on or off. From on, immediately it will go to off. Off, immediately it will go to on. So that quick response will be there. If you if you use electromagnetic relay, first the supply has to go to the coil, and then that coil will consume some energy, and then only it will start producing the flux. That flux, it has to create sufficient magnetizing energy, so it will take extra time. So there is a possibility of response may be little slower, but it won't much slower. But when compared to static relay, electromagnetic relay will be a bit slower. And then this one, very simple components, so it will be long life and high reliability and more accurate. And immediately you can reset the relay in very less time. Okay, because on and off, if you give gate signal, it will work. If you remove gate signal, it will not work. It kind of, okay. So it depends upon that base signal or gate signal, its operating condition. So immediately you can set or reset. That is easy. It does not have any thermal storage problem. Why means very small components, small operation, just on and off, that operation only. But when you are going for electromagnetic relay, more current will flow to produce sufficient flux. So there, if current flows, automatically there will be temperature rise. Temperature rise. So you may have to keep that relay in relay with cooling arrangement. In some cases. So the thermal storage problem will be there with electromagnetic relay, but in static relay, generally it won't require that generally it won't face thermal storage issues and all. As I have already mentioned, here only 1 or 0, on or off. But in electromagnetic relay, if saturation happens, magnetic saturation happens, then unwanted tripping also. We may give low current, but already available current which having residual flux, that residual flux may may create unwanted tripping. So similarly, the static relay has various limitations also, like overload capacity. Overload capacity is very less when compared to the electromagnetic relay, because it is able to withstand high current, but the electronic component it will not able to withstand that high current, because you're going to control the electrical equipment, we're going to control the electrical we're going to protect the electrical equipment like motor, heavy generator. So these generator motor is going to work with heavy current. In that case, if you are using electronic component, then that heavy current due to overloading or any fault occurs, this relay may not withstand that. So that is why they are mentioning its overloading capacity is very less. And similarly, they will be using various technology in order to keep multiple transistor as a single chip. So the technology to use this VLSI technology, VHDL, many technology they will use for making the electronic component to be compact. So in that case, when compared to the electromagnetic relay, just a coil over there in electromagnetic relay, but static relay, multiple transistor, multiple SCR in a single chip. If you are using, the technology itself will cost us more. So that is why the static relay is costlier as compared to the electromagnetic relay. And there is a possibility of surrounding interference may distract the operation of relay. Then next one, comparator. Comparator, we need to identify whether it is a fault current or normal current, fault voltage or normal voltage. So we need a comparator, and similarly our current or voltage waveform is following the proper phase angle or not. Sometimes magnitude may be same, but phase angle may differ. This also will affect the load. So in that case, phase angle, everything is important for particular we used to say 230 voltage 50 hertz is a standard supply. Instead of that 230 voltage 100 hertz, like that, if you are applying frequency, that waveform, it varies, then that also it is a fault supply which you are applying to the load. So frequent, not only the voltage magnitude or current magnitude, also that frequency, a phase angle, that is also important. So in order to compare whether are we getting same amount of same magnitude of voltage or same magnitude of current or same phase angle for the normal and actual phase angle of voltage and current, this needs to be compared. Accordingly, the static relay will be given signal. Comparator only will compare. If any error identified, that error will be given as a signal for the static relay to get operate, so that it will protect the circuit. So the main thing, the static relay is used to distinguish it and gives a trip signal to the circuit breaker. So various types of comparators are available. One is amplitude comparator, the other one is phase comparator. Amplitude comparator, that means the magnitude of two quantity like actual, and actual means at present what is the current flowing in my generator, and what is the fault current, that limit they will check. If both are equal, okay, it reaches fault supply, or it's going beyond the normal supply. So like that it will compare. For that, the comparators required. This whatever I have said, which will compare only the magnitude. Phase comparator, the phase angle between one quantity and the other quantity, if it is lesser than 90 degree, then that is considered as a fault. Okay, So then for that, this relay will this comparator will give a signal, so that the comparator will make the relay to sense, and then the relay will give signal to what current circuit breaker. That's what here they have mentioned. Compares phase angle of two quantities, just a phase angle, okay, irrespective of their magnitude. That is most important. There may be the magnitude may be equal, okay. What normal current and what is the actual current? Current is flowing and normal current. It may be equal, but phase angle, if it differs, that also what consider as what fault condition. Duality between amplitude and phase comparator. Duality means dual operation. Two operations can be done by a single comparator. So my amplitude comparator, if I change the given input, okay, instead of m and n are two quantity, okay, that two quantity we are checking. Instead of that, if I do m plus n and m minus n, if I change the input, instead of m and n, if I change the input as m plus n and m minus n, this amplitude comparator can be made to work as phase comparator. So if you change this input, you can check what the amplitude comparator will able to check m plus n magnitude is greater than m minus n. This condition satisfies when what? When my angle is lesser than 90. So but it is going to compare what amplitude only, but which will help us to identify what is the angle. If in case my m plus n is greater than m minus n, consider, then which will indirectly will say my phase angle. Phase angle means the angle between this m and n is lesser than 90. That is what it is saying indirectly. So here you can see amplitude comparator used for phase comparison. An amplitude comparator can be converted to a phase comparator and vice versa. Okay, it can be vice versa. Phase comparator can work as amplitude, amplitude can work as phase comparator, and vice versa. If the input quantities to the comparators are modified, okay, input quantity here m and n. Instead of that, we are going to use m plus n and m minus n. Then the next one, here that explanation only they are giving elaborately. The modified inputs are the sum and difference of the original two input quantities. Okay. Amplitude comparator will just check m is greater than or n. If m is greater than n, then this comparator will give us output. That means this is a fault condition. Okay, so n is a normal current. Consider normal current. Okay, if a current goes beyond the normal current, m is the current, actual current. So the actual current goes beyond the normal current, then this amplitude comparator will show an error. So in order to make the amplitude comparator as a phase comparator, m plus n and m minus n, we are converting m and n as m plus n and m minus n, and then this m plus n is greater than m minus n. In this case, my phase angle between m and n, actually my amplitude comparator is comparing only m and n magnitude, but if I change the input like m plus n and m minus n like that as a two inputs, if this condition happens, that means it is indirectly saying the angle between that m and n is lesser than 90. That means my output is having some fault, some error. Okay, so given input is going beyond the required phase angle. So that means as per the phase angle, it shows some error. So in this phasor diagram, you will be able to identify where the comparator will make the relay to work, because comparator need to give a error signal, then only the error, using that error signal only my relay will work. So here they are not comparing the magnitude, they are just making that dual operation. So here you can see M, N. Okay, so using this M and N, we will be getting M plus N and M minus N. Okay, so in this case, when compared to M plus N, your M minus N is greater. But when your comparator will give us output when M plus N is greater than M minus N. Okay, in first you will see this one, M plus N is lesser than, the length you can check. Here M minus N is greater than M plus N. Okay, so the angle between, so from this, the angle between M and N, you can check, it is greater than 90. So in this case, my comparator will not show any error. Here M and N both are in equal length. Okay, equal in length means then M minus N and M plus N, you can draw this one. Okay, by drawing the parallel line, you can draw M plus N and M minus N. So from this, you can see the angle will be exactly 90 degree. So in this case also, my amplitude comparator is indirectly showing that angle. Okay, phase angle. Okay, similarly, it is showing the phase angle for pi equal to 90 degree for this condition, M plus N and is equal to M minus N. Then the next one, M plus N is greater than M minus N. In this case, you can see my M plus N is greater than M minus N. You can see my angle will be lesser than 90. So here at diagram C, you can expect the comparator to give output so that the relay will work. So that's what they have mentioned here. Phi angle will be lesser than 90. So here phase comparator used as a amplitude comparator. Till now we have seen amplitude comparator to work as phase comparator. Here this phase comparator is going to work as amplitude comparator. So take phase comparator M and N as an input. If the angle between M and N is lesser than 90, then this will give us output. Okay. That input, if you vary, as I've already mentioned, how that amplitude comparators can be converted as a phase comparator with the help of changing the input. Similarly, here the phase comparator is going to work as amplitude comparator with the help of M plus, the variation of input M plus N and M minus N. Okay, so in this case, the angle will be, for these two input, angle will be lesser than 90. When it will be operating means it should be angle lesser than 90. Already, okay, phase comparator angle only, no. But this angle, it shows indirectly my M quantity is greater than N quantity. M should be greater than N. This one already we have seen. M is greater than N, amplitude comparator will work. So your phase comparator to work as amplitude comparator means then my M should be greater than N. Once if you see the phasor diagram, you will be able to understand. You can see here your M is lesser than N. You can check N quantity, N magnitude and M magnitude. Okay. So here the angle will be what? Lesser, more than 90. Here exactly 90. You can check m minus n and m plus n. Okay. Here this is m plus n, this is m minus n. Why m plus n and m minus n they are comparing is that what is the input you are giving? M plus n and m minus n. So the angle between these two only will make this phase comparator to work as an amplitude comparator. Angle between these two. That is why this angle they are checking. Okay, m minus n and m plus n. Accordingly, m and n already we are aware. So you can see here, actually here the angle will be exactly 90. Don't draw like greater than 90. Here this only greater than 90. This will be exactly 90. M plus n and m minus n exactly 90. Okay, that alone you have to change. And then here m is greater than n at my angle will be lesser than 90. That you can see here. M length is greater when compared to n length. Okay, so here the angle between m minus n and m plus n will be what, like this. The length will be same, m plus n and m minus n. Okay, but the angle will be lesser than 90 degree. Okay, so in this case my comparator will make the relay to work. So here they were using AND gate logic. AND gate means all the input should be 1. Then only it will give the signal to the trip circuit, because all input 1, output will be 1. If any one input is 0, your output will be 0. Okay. 1 second, please wait.